Alright, so in this video we're going to be talking about the equation of the tangent line that that we're working on generating. So in this video we're going to work with the function y equals a third x cubed, and we'll go ahead and make a little graph. Okay, we got y, we got x, and then of course you got that little weird squiggly thing going on here. Looks something like that. Alright, so we're going to work on the tangent line at, I don't know, let's do it at x equals 2. Okay, so we got 1, 2, right here. It's right here. So first thing we need to do, when you're looking for a line, you're going to have y equals mx plus b, right? So the two things that we need are m and b, and then x and y we can figure out later. So let's go ahead and do this. Using our limit definition of a derivative, which I'll go ahead and write out again, which is m tan equals the limit as h is approaching 0 of the function of x plus h plus, minus f of x, bogged down a little bit here. So we got minus f of x over h. Alright, and then this is the limit definition of the derivative that we've been using. So let's go ahead and find m for this function over here. So m equals the limit as h is approaching 0, and we want to find f of x plus h. What is f of x plus h? Well, it's going to be a third times x plus h cubed minus f of x, which is, let's see here, x is equal to 2, right? So we'll do 2 plus h cubed. Okay, and then minus a third times 2 cubed. Okay, and then divide that by h. And this is going to be the thing that we're working out, so I thought it would be good to go ahead and get a little more practice. You guys, again, can always go back to OpenStax Calculus 1. They have a free book online. Just go to chapter, I don't know, I think it's in chapter 2 or 3. You can go in there and work some problems out. So let's go ahead and crank this out. So 2 plus h cubed. That's going to give us 4 plus 4h plus h squared times another 2 plus h. Let's factor out a third over here and have that multiplied by the whole thing, and then we got minus 2 cubed, which is 8. All that's divided by h. And we can add that limit in later, but we'll go ahead and just keep working this out. So again, that top part, we got 4 times 2, that's going to be 8 plus 8h plus 2h squared plus another 4h plus 4h squared, right? Yeah. Alright, and then we got plus h cubed minus 8. Alright, and then we divide the whole thing by h. Okay, first good thing, well, don't forget the 1/3. Multiplied by the whole thing. Now we got these 8's cancel out here. And then let's see here. Let's go ahead and cancel out an h from everything. So we got an h canceling out there, and there, and there, and there, and then this will become h squared, and that cancels out with that. Okay, so that'll give us, let's see, we got 8 plus 4 is 12 plus, what is that, 2h plus 4h. Could have made that 6h, but we'll just leave it. Plus h squared. Okay, and this is all times a third. Okay, and then again, don't forget that it is the limit as h is approaching 0. Now, all of these ones with h's, all of those terms are just going to go to 0 as h is approaching 0. And then what we're left is 1/3 times 12, which will give us 4, right? So we have the limit as h is approaching 0. Of, what's 12 divided by 3? 4. Actually, I'm sorry, it'll just be 4. Go ahead and write that. Alright, so the answer is 4. Let's make sure that's right. Let me double check it. Alright, awesome. That is in fact correct. The limit is 4, so this is our slope, which we will call m, right? So we have m equals 4, and that gives us the first part of the equation that we were looking for earlier. So we have y equals mx plus b. We have our m. Now we just need our b. So what we'll do is we'll use, I believe it's called point slope form back from algebra, and we'll plug that in there. So we have y minus y1, which let's go ahead and find out what y is whenever x equals when x equals 2. So y equals 2 cubed over 3, which equals 8 thirds. Okay, cool. So 8 thirds is our y1. Okay, so let's go to our form, our point slope form, which is y minus y1 equals m times x minus x1. Okay, now using this form we can actually find the equation of our tangent line. So we have a point which is 2 and 8 thirds and our slope which is 4. So we have y minus 8 thirds is equal to 4, come on, times x minus 2. Okay, so we have y equals 4x minus 8 plus 8 thirds. Okay, so we have 8 thirds minus 8, which is negative 16 thirds. So we have y equals 4x minus 16 thirds. And that should give us our answer. Alright, so that is how we can find the equation of the tangent line at x equals 2. So that'll be this line right here. And let's make sure it makes sense. We do know that the coefficient on x should be positive because it's going up. It has a positive slope, so that's good. And these are just some little mental checks you can do in your own head to make sure that your answer is reasonable. But yeah, so what we did was we took y equals mx plus b, used the limit definition of the derivative to find the slope, and then plug that back into point slope form with our point from the original graph to find the tangent line at that point. Alright, so in the next few videos we'll be talking about how we can find the derivatives of different kinds of functions, trigonometric, exponential, etc. So we'll see you in the next video.